Bismillahirrahmanirrahim. Today we are going to solve Cambridge O-Level Physics Paper 2 Theory for the session of May-June 2024, and we have the subject code 5054 and the variant of the paper is 22. We have 1 hour 45 minutes for this paper, and this paper is carrying 80 marks. Another important information that is written in this in the instructions are that we need to take the value of g, that is equal to 9.8 meter per second squared. We're gonna start our question paper from question number 1. Question number 1 is that figure 5.1 shows two trolleys. On the front of trolley A there is a wooden road. Trolley B is initially at rest. Okay, it means that this trolley is at the rest, so its initial speed would be 0. As trolley A moves towards the right, the road ends the modeling clay. Trolley A slows down and trolley B start moving, and it means it carries the momentum to trolley B. The trolley then sticks together and continue moving towards the right. Okay. Figure 1.2 show the speed time graph for the trolley A and the trolley B and their combined speed as well. The trolley starts to collide at time t is equal to 0.3 second at t is equal to 0.5. Okay, we know that trolley start to collide at this point and this point. When this trolley A collides with trolley B, this trolley B starts accelerating. Okay, start moving. The trolleys are moving at the same speed. State how figure 1.2 show that during the collision trolley B has a uniform acceleration. As we can see that it is a speed time graph, and in speed time graph then there is a straight line. It means that trolley B is moving with the constant speed, or you can say that a straight line from 0.3 till 0.5 means that it has a uniform gradient. That's why it is moving with uniform acceleration. So a straight line from t is equal to 0.3 to 0.5 represent uniform gradient, thus acceleration is uniform. Moving to its next part, describe how the graph in the figure 1.2 show that magnitude size of the acceleration of the trolley B is larger than the magnitude of the deceleration of trolley A. Okay, we can tell by the steepness of the graph, and we can write, because it is a 1 mark question, so you can simply write that the trolley B has a more steeper graph. But if you can explain for understanding of yourself how trolley B is moving, so you can see from the figure that it is moving from 0 to 0.5. it means 0.4 it has gained the velocity, and this velocity is 0.7 and it is 0.4. it means 0.7 to 0.4 its velocity decreases to 0.3. Now you can see 0.7 to 0.4, it means velocity decreases to 0.3. And on the other hand, for the trolley B, its velocity increases from 0 to 0.4. it means trolley B has a gain of 0.4 and trolley B has decelerating with 0.3. so it proves that this trolley B is more accelerating compared to trolley A. So we're gonna write that change in velocity of trolley B is greater than A. B changes from 0 to 0.4, while in A it changes from 0.7 to 0.4. so it clearly shows that. Or you can write the steepness of the graph, because it is a 1 mark question. Moving to its next part. Next part is that calculate the acceleration of trolley B when t is equal to 0.4 second. Okay, it means we need to calculate the acceleration. We know that the formula for the acceleration is change in velocity over change in time. Acceleration is the rate of change of velocity. So delta V we're gonna take as 0.4 minus 0, and the time interval is 0.5 to 0.3. After subtracting it, we would get our answer 2 meter per second square, or you can write our answer here. Moving to its B part, the mass of the trolley A is equal to 0.8 kg and the mass of the trolley B is 0.6 kg. State show that momentum is conserved in the collision. What is the conservation of momentum? That momentum remains constant, or the momentum before the collision and after the collision must be equal. So we're going to calculate before the collision. In the formula would be mv, and after the collision the formula would be mu, or you can say mv, and the mass is 0.8 for the trolley A and 0.7 is the velocity, and the mass over here would be 0.8 plus 0.6. Why we added after the collision? Because both masses are gonna add up because they are moving in the same direction, and the velocity would be 0.4. So we can see that this answer would be 0.56 and this answer would also be 0.56. So it shows that momentum of the system is conserved. So it is clearly shown by the mathematical calculation. Moving to its C part, in another collision between the same trolleys, the rod and modeling clay are not present. Trolley A hits trolley B at the same initial speed. Explain why the force between the trolleys larger in the collision. Okay, it is taking another scenario, and the other scenario say that rod and modeling clays are not present. Trolley A hits trolley with B with the same initial speed. It means that time of contact during reduces change. It means the collision would happen soon. So change in momentum is constant. Time is smaller due to the rigidness of the trolley, leading to greater forces on the trolley because now they have the some amount of initial speed. So this was an easy explanation. Moving to question number 2. Question number 2 is in figure 2.1 shows a small swimming pool containing water. Okay, we can clearly see that it has also the dimension 2.1 and 4, and if we have to take its height for the calculation of volume. Okay, the depth of the water is 0.8. So we can write over here this is 0.8. The density of the water is 1000 kilograms. Density is given. Show that the mass of the water in the water pool is approximately 6700 kilograms. I am underlining this word. Some student confused when their answer doesn't exactly match up to the 67. So examiner has mentioned it should be approximately equal to 6700. So the formula for the density is equal to mass over volume, and we need to calculate the mass, that is equal to density into volume. The volume the density value is given, that is 1000, and for volume we need to multiply length, breadth and height, and it would be 4 into 2.1 into 0.8. Okay, after multiplying it we will get that our answer would be 6720, that is approximately equal to 6700 kilogram when we convert it to into two significant figure. So this was an easy question, simple calculation. Okay, define pressure. Pressure is the force per unit area. So again you can write P is equal to F over A, or you can write as well pressure is equal to force per unit area. So this was an easy 1 mark question. Over the year, pressure is the examiner's favorite topic. Always examiner give a question from pressure. Okay, calculate the pressure on the base of the pool due to the water. We know that the pressure has the formula, that is P is equal to rho GH. P is equal to rho GH, and the value of density is given, that is 1000, and from the instruction we know that we need to use 9.8 over G value, and the height of the swimming pool is 0.8 meter, that is mentioned as a depth, or we have written as well. Okay, so we're gonna multiply them and we get the answer, that is equal to 7840 Pascal, or you can write into two significant figures 7800 Pascal. Okay. You can also calculate this by your formula for pressure, that is P is equal to, or I am writing over here, you can choose either of method, both method will be considered correct. And the force we know that is equal to mg, and area we know that equal to length into breadth. The value of m is given, that is we just calculated in the first part, that was 6700, and the value of g is 9.8. then the value of the length and the breadth is equal to 2.1 and into 4. After solving it, we get the value that is equal to 7816 Pascal, that is approximately 7800 Pascal when we convert it into two significant figure. So both methods are considered correct. Over here you can choose either of the method. I shown calculation with whichever method which you find more easy, or whatever comes in the mind first doing solving this paper. So there is no problem in choosing either of it. Okay, moving to its fourth part, the water in the pool. The water in the pool is initially at a temperature of 10 degrees Celsius. The temperature rises when 5.1 into 10 raised to the power 8 joules of energy is transferred to the water. The specific heat of water is 4200 joule per kg Celsius. Calculate the final temperature of the water. So this is very interesting question. Examiner has played some trick over here. Okay, but the trick is so easy. Q is equal to mc delta T, and we know that for temperature delta T would be Q over mc. The value of Q is given, that is this 5.1 into 10 raised to the power 8. Okay, and value of m is also given, that is 6700, and the value of heat capacity, that is 4200, that is also given. After calculating, we get the value that is equal to 17.7 degrees Celsius, but we need to calculate the final temperature. So delta T is equal to T2 minus T1, and T2 has a value of 17.7. T2 we need to find out the final temperature, and T1 is 10 degree Celsius, that is also mentioned in the question. Then the value of T2 would be 17.7 plus 10, and the final temperature has a value of 27.7 degree Celsius, or you can round it to 28 degree Celsius, giving your answer into two significant figure. So first you need to calculate delta T. After calculating delta T, you have to apply T2 minus T1. Mostly the question, most of the student will consider their question is completed over here. No, it's not completed until you get the final temperature. Delta T is the change in temperature, not the final temperature. Okay, moving to its B part, explain in terms of movement of particles how evaporation causes cooling. Okay, evaporation means leaving the high energy particles from the surface, because we know that evaporation happens at the surface of the liquid. So when the high energy particle leave the surface, the low energy particle remains the surface. That's why evaporation causes cooling. Okay, we can write particles with more kinetic energy scrape the surface of the liquid, leaving behind particles with lower kinetic energy, causing the cooling effect. This is a very easy question, but in very important concept. Okay, second part is changes to factor in the environment of the swimming pool can cause an increase or decrease in the amount of evaporation from the surface of the water. State two changes of to environmental factor that increases the amount of evaporation from the surface of the water. So we know that if temperature is high, or low humidity or wind pressure could also increase that. So we can write our answer higher temperature wind pressure, you can write, or you can write low humidity. Any two factors are needed to write to get 1 mark. Okay, so this is how we have completed question number 2. Now moving to question number 3. Question number 3 is a very intelligent question from the examiner. It shows how it evaluate the current applications related to electricity. Figure 3.1 shows a solar powered charger connected to a cell phone or mobile phone. So this is solar, and the battery inside the cell phone is charged by a solar powered charger. Complete figure 3.2 to show the useful transfer of energy from the sun to the battery. We know that sun has a nuclear energy, and energy is changes into chemical. Okay, explain why the battery takes long time to charge on a cloudy day. Because the sun rays are less available in the cloudy days, and solar radiations reaching to the solar panel is very less, and hence the less kinetic energy or electrical energy is produced. So you're gonna write that less radiation reaching the solar panel, and hence less electrical energy is produced. Moving to B part. After use the outside surface of the cell phone. Okay, cell phone is warm, then switched off. The cell phone cools down. Name and describe 3 processes by which thermal energy is transferred as the cell phone cool down. So we're gonna write conduction, convection, and radiation. So conduction happens from the phone surface to the air particles because they are in direct contact. Next, convection, as the hot air rises up because it has a low density, so that's why it rises up. And radiation, infrared radiation emitted from the surface of the phone. So that's how energy is transferred and it phone cool down. Moving to C part. Okay, C part is that now you can see. Okay, just gonna straight paper over here. Okay, now C part is that it takes 4.5 hours to charge the battery with an average current of 300 milliampere. Calculate the quantity of charge that enters the battery. Give your answer, give the unit of your answer. So we know that formula of calculating the current is I is equal to Q by T, but we need to calculate the charge, and charge is Q is equal to IT, and the value is given of current, that is 300 milliampere. We're gonna convert into ampere, 300 into 10, and the time is given, that is 4.5. so we're gonna multiply with the time, but it is in hours, so we're gonna convert it into seconds by multiplying into 3600. After multiplying, we get the answer, that is equal to 4860 coulomb. So we're gonna write our answer into significant figure 4900, and the units are in coulomb. So we know that charge has a unit of coulomb. So this is how we have completed question number 3. Hopefully you get the understanding of it. Moving to question number 4. Question number 4 is from the topic of light, and figure 4.1 shows the light passing through a triangular passing through a triangular glass prism. State the value of angle of incidence at point P. So at point P, the value of angle of incidence, because it is moving straight, so the angle of incidence would be 0 degree. So you don't need to write degree is present over here, and if you can write, you would write, it would not consider as wrong. Okay, draw the normal and the angle of incidence at the point R. So we need to draw the normal at the point R. So how you would draw it? By drawing the normal over here, and this angle would be the normal angle, 90 degree. So this is how you would show it, and label the angle of incidence, and this would be the angle of incidence because this ray would be over here. Okay, moving to its moving to its third part, state two condition that needed that no light refracts from the glass into the air at a point q. So at point q, angle of incidence should be greater than angle of critical. So we're gonna write that angle of incidence is greater than the critical angle, and the light must travel from denser medium to the rare medium. So we're gonna write these two conditions for when no lights refract from glass into the air. Moving to its B part, information is sent across the internet using pulses of visible light through long thin glass fiber and electrical signal through copper wire. State the name of one other type of electromagnetic radiation that is used to transmit information through long thin glass fiber. So you can write that infrared radiation that we use in TV remotes. You can write simply infrared. Okay. Next part is suggest two advantages of using glass fiber rather than copper wires to transmit information from the internet. So we know that from optical fiber there will be total internet reflection, and then more calls will happen, and there will be less interference, and the speed of the communication would be faster, and it would produce less noise. So you can write any 2 points that would be considered valid because it is carrying only 2 marks. So I have written 4 marks, but 4 points, but you need to write only 2 points. Okay, moving to question number 5. An initially uncharged rubber balloon is rubbed with a woolen cloth. Static charge is rubbing the balloon causes the balloon to have a negative charge. It means that balloon have a negative charge. So balloon gains electrons. So that's why balloons have a negative charge, and now has a negative. Woolen cloth loses dash. Woolen cloth obviously loses electrons, and now it will become positively charged body. Okay, and now it has a positive charge. So this was an easy 2 mark from static charges. Okay, on figure 5.1, complete the level. We have done that. Explain why the balloon stays negatively charged for a long period of time. Balloon is made of an insulating material, and electrons are unable to move and be carried away from the balloon. So that's why negative charge stay longer at the balloon. This was again from the static charges, and very important explanation is written over here. You can take the screenshot. Okay, moving to its B part, rubbing the balloon causes the temperature of the air inside to rise due to friction. Explain in terms of particles of air why the volume of the balloon increases when the temperature of the air rises. This is the concept of Charles' law. Volume is directly proportional to the temperature. At higher temperature, we're gonna write the air particles, they'll have more energy, they will move faster and have more kinetic energy. The molecules will collide with the walls of the container at higher speed. So this causes pressure, and they would vibrate more, they would expand more, and it would cause the balloon to expand. So this is the simple explanation. Moving to question number 6. Question number 6 is from the practical electricity and DC circuit, or you can say it's from the practical electricity completely. Figure 6.1 shows a circuit diagram containing a battery, and LDR and a fixed resistor. Whenever it is LDR, it means its resistance is inversely proportional to the amount of light. When the light is light falls on this LDR, its resistance decreases. There is a lamp near the circuit. Light from the lamp incident on the LDR when the lamp is switched on. Okay, figure 6.2 shows that the current voltage graph for the LDR with the lamp switched on with the lamp switched off. There is a two situation when the lamp switched on. When the lamp switch on, it has a current 0.1 because LDR resistance would decrease when the light is on, and when the switch is off, it has a low value of the current, but voltage in both cases are same. Okay, next part is A part. State Ohm's law. Ohm's law is that current is directly proportional to the potential difference provided that temperature and or any other physical state remains constant. You can also give this or you can write as well V is equal to IR. Next part, explain how the graph lines in figure 6.2 show that Ohm's law applied to the LDR because they are the straight line, and for ohmic conductor it is always straight line. So graph is straight line passing from the origin, or you can write it is simply the straight line. Graph is straight line passing from the origin. Okay. Moving to its C part, use values from figure 6.2 to explain the effect of the LDR of the. I have already explained that whenever on the LDR the light is emitted or light is fall, its resistance decreases. That's why circuit will on and the current will pass. Okay, so we're gonna write that at voltage 6 V is equal to 8, and we know that in both cases the voltage is same. Current in LDR is 0.06 ampere, giving a resistance of 130 ohm. How we have calculated? By formula of V is equal to IR, and R is equal to V by I. So you can apply 130 ohm, or you can simply write the explanation. When the light is off at the same voltage, current in the LDR is 0.1 and the resistance is 80 ohm. This how you have calculated. Okay, I'm writing this formula for your better understanding. R is equal to V by I. So you can divide it and get that, and this would happen. Okay, with the lamp switched on, the current on the LDR is 0.05 ampere. Determine the current in the fixed resistor for the first part. Okay, because it is connected in the series, so in series circuit the current would remain same. So this was an easy question. You don't need to calculate anything, you just need to know the reason that in series circuit the current would remain the same. Okay, next part, calculate the EMF force of the cell, and we know that formula for the EMF potential difference V is equal to IR, and we know the value of current that is equal to 0.05, and the value of resistance is 240. We get the value that is equal to 12 volts, and we know that when I is equal to 0.05 volt, then V is equal to 4 volt, and we know that EMF of battery would be 4 plus 12, that is equal to 16 volt. How we calculated V is equal to 4 volt? I am going to show you that from the graph. When 0.4 and this line would match over here, so this is 4 voltage. From the graph you have calculated the value of 4, so I am writing over here from graph so you don't confuse. Okay, so our answer would be 16 volt. Moving to question number 7. Okay, question number 7 is from magnetism and electromagnetic induction. A plotting compass contains a needle. The needle is a small magnet that can rotate about its center. Figure 7 point show the plotting compass placed close to the bar magnet. On figure 7.1, mark the magnetic poles on the bar magnet. So at the bar magnet, we know that there would be attraction, so it would be north and it would be south over here. So this was an easy question. There is a piece of paper underneath the magnet. Okay, there is a piece of paper underneath the magnet. Describe how the compass is used to plot the magnetic field lines from one pole to another pole. This is a very simple question. First, I will explain you through the figure. You will put your compass here. It will point north and south again, until you reaches the other end. So it would be like that. Mark the north end of the compass. Replace the compass in such a way that south of the compass matches the north. Repeat until the compass touches the other end. It means that you need to put compass over here, until you reach in the other direction. So moving to its next part, describe how to use the compass in figure 7.1 to determine the direction of the magnetic field at P. P is this point. This is the simple. You need to put magnetic compass over here and you will find the direction. Place the compass at point P and draw the direction shown by the compass. Simple. You would get the 1 marks from this explanation. Okay, moving to its B part. This is from electromagnetic induction. This is a very important question because this question is touching magnetic flux. Okay, I will explain during the answer. Figure 7.2 shows the apparatus a student uses to produce an AC alternating current. Okay, magnet is, and this is coil. The magnet is moved into and out of the coil. It means, okay, explain why a current is produced when the magnetic, because current is produced due to the magnetic flux. What is magnetic flux? Magnetic flux is the number of magnetic field lines passing through unit per unit area. When number of field lines passing through unit area increases, its flux increases. When it decreases, its flux decreases. So the change in flux will produce the current. So it will induce EMF. So we would write that magnetic field cuts the coil on the magnetic flux changes in the coil induces an EMF by induction. Or you can simply write due to the change of the magnetic flux, it will induce an EMF. Okay, moving to its second part, describe the movement of the magnet produces an AC of frequency 0.5 Hertz. Time we know that is equal to 1 over F and 1 over 0.5 it would be 2 second time period. Moves the magnet in and out in every 2 seconds. So this is the simple question. You can give explanation or you can give calculation. Either of it would be considered correct. Describe how the center 0 ammeter show the current in AC rather than DC. Reading positive and negative both sides, because 0 is in the center. It means it can go over here, it can go over here. So it means that it can go in both directions. So it would indicate its voltage is changing. So that's why it is U. Okay. Explain by increasing the frequency of the AC produce also increases the magnitude of the, because when you change the voltage more, it would induce more, and the larger rate of change of flux will produce larger current. So this is how we have completed this question. Moving to question number 8. Question number 8 is from the atomic physics. Picture figure 8.1 is a picture of nebula formed from a supernova. Okay, state what is meant by supernova. We know that supernova is the explosion of a red giant at the end of its life cycle. Moving to its B part, describe how protostar form inside a nebula. We know that protostar is the initial clouds of the gas collapses due to its own gravitational pull, causing an increase in the temperature of the cloud of a gas. Moving to C part, our sun is a circular orbit around a black hole in the center of gravity. State the name of galaxy that contains the sun. We know that our galaxy name is Milky Way. State what is meant by light year. Distance traveled by light in 1 year. So we're gonna write that distance travel by light in 1 year. Okay. Next part is the time taken for one complete orbit of our sun around the black hole is 7.3 into 10 is for 15 seconds. This is a very interesting calculation question. The distance from our sun to the black hole is 26,000 light years. 1 year is equal to 3.2 into 10 to the power 7 seconds. Speed of the light is given, that is 3 into 10 to the power 8 meter per second. Calculate the speed of our sun as it orbits the black hole. Show your working and give your answer in meter per second. So we know that we have the formula of speed, that is equal to distance over time, and distance over here is 2 pi r. You can write r as capital over t. So we're going to apply this formula over here. 2 multiplied by pi and r. What would be the r? We will calculate r by like distance. R is equal to distance, and distance is equal, now you can see r is equal to distance. This r is equal to distance, and distance is equal to speed into time. So we're gonna apply speed. What is speed into time? So the speed of the light is 3 into 10 to the power 8. And what is time? We know that time is 26,000 light year. And 1 light year is equal to 3.2 into 10 to the power 7. Now you need to divide it by time, and we know that this is the time that is given. So we're gonna write over here 7.3 into 10 to the power 15. Mostly students will do mistake over here. So I am repeating it. S is equal to d by t, 2 pi r over t, and d is equal to r, and r is equal to speed into time. So we have right speed of light and then multiplying by time and then converting into light year. So after dividing it, we get the answer that is equal to, okay, that is equal to 214,830, and this is equal to meter per second. Or you can write 2.1 into 10 is to the power 5 meter per second. So this was a question that's carrying 3 marks. Moving to last question of our paper, question number 9. That is from the topic of radiation. Alpha particles are sometimes emitted from the nuclei of a radioactive element. The emission is both random and spontaneous. What is meant by spontaneous? Emission means it happens on its own. We do not control it. The emission happens on its own and it is not affected by the external factors like temperature, pressure, or radiation. Next part, B part. Describe the composition of an alpha particle. We know that alpha particle is a helium particle and it contains 2 protons and 2 electrons. Moving to C part. C part is very interesting part over here. Examiner first time asked this question. Alpha particles are detected using the tracks shown in the cloud chamber or by the spark produced in a spark counter. Describe the structure, either a cloud chamber or a spark counter. Include a label drawing of this apparatus. You need to just lay out the diagram. I will put the exact diagram of it of cloud chamber and spark counter over here. Now you can see it as well. So you can write radiation ionizes the air between the particles, between the plate. Charges separates between plates due to high voltage. This leads to spark. Next part is describe how the emission of alpha particle is shown as random in the operators you describe in part C. Spark counter reading varies and it fluctuates. So this is a simple explanation. Moving to last part of our question, it is that a radioactive a radioactive source produces 120 tracks in 1 minute in a cloud chamber. 6 hours later, the same source produces 15 tracks in 1 minute. Without the source present, no tracks are produced. Calculate the half-life of the isotopes in the source. So this was an easy question. We know that we have 120 tracks. And half-life would be 60 after half, and it would be 30, and it would be 15. So we know that 6 hours later the same source produces 15 tracks in a minute, so it reduces to 15. So it would be first, it would be second, it would be third. It means 3 half-lives is equal to 6 hours. So we're gonna calculate 1 half-life by dividing 6 by 3. So we get that 2 hours. So this was our last question. Hopefully you get the understanding of this paper. If you do have any queries related to the paper, you can ask in the comment section. Your answer will be discussed, or you will be explained in detail. And do share with your friends who required help in the physics, and do not forget to subscribe my channel for getting further videos and updates. Thank you so much for watching this video. Allah Hafiz.